Hello everyone, in this training video, I'll walk you through how to set up auto-scaling for Kasm Workspaces on Oracle Cloud Infrastructure, short for OCI. Kasm Workspaces features an advanced auto-scaling capability that can automatically provision Docker agents based on demand, supporting a variety of providers like AWS, Azure, DigitalOcean, Google Cloud, Harvester, KubeVirt, OpenStack, and Oracle Cloud. In this video, we will focus specifically on setting up and optimizing auto-scaling with Oracle Cloud Infrastructure. We'll begin with an overview of key components such as zones, pools, and the connection proxy. Following that, I'll take you through a live demonstration where we'll set up and configure the auto-scaling feature in real time. Finally, I'll showcase the results of our auto-scaling setup. Before we set up auto-scaling, it is important to understand some Kasm concepts like zones, pools, and connection proxies. Deployment zones in Kasm enable logical grouping of Kasm services according to your infrastructure needs. Two most common strategies that are used by our customers are geographical zones and workflow/department zones. In geographical zones, the Kasm services are strategically distributed across multiple geographical regions to minimize latency and enhance connection speeds. This setup is particularly beneficial for organizations with a widespread user base across different continents or regions. For instance, you could establish one zone in Virginia or more broadly in United States and another zone to serve users in the Asia Pacific region or Australia. The other common deployment zone strategy is grouping by workflow. This is most commonly used by large or siloed organizations that need to maintain strict isolation between different departments for security reasons. An example for this would be to create a separate zone for the marketing department and a separate zone for the engineering department. When setting up a deployment zone in Kasm Workspaces, there are several important configurations to consider. I'll guide you through each of these settings, explaining what they are and how to configure them. The first setting that you can configure is called Allow Origin Domain. This is an optional setting that enhances security by restricting Kasm session connections exclusively to authorized origin domains. You can set this to the base domain of your deployment. The default value for this would be the request host parameter that dynamically uses the domain name from the incoming user request. In the live demonstration later in this presentation, I'll be using my deployment hosted at teja.kasm.technology. So I will use the same FQDN for this setting to make sure all the connections to my Kasm sessions come exclusively from my authorized origin domain. The next setting is called the upstream auth address. This is the address of the Kasm API server that your sessions are authenticated against, and it's really important to configure this correctly. On a single server configuration, the default value for this is proxy, which utilizes the local proxy for authentication. On a multi-region or a multi-server deployment, you need to set this to the IP or fully qualified domain name of the specific Kasm resource that you want to connect to, where the Kasm API is also available. In my demo environment that uses a minimal infrastructure, I will set this to teja.kasm.technology. This is because it's the primary Kasm resource in my setup that hosts the Kasm API server. Your API server might sit behind a load balancer or a proxy, and you need to configure this correctly so that the connections to the Kasm sessions can be authenticated. The next configurable option is the load balancer strategy. This is the strategy that Kasm will use when a user requests a new Kasm session. There are different options that you can select for this. If you select least load, the system will prioritize the agents with the least consumed CPU/memory resources. This strategy is useful when you want to ensure that sessions are distributed to the least busy agents, optimizing resource utilization. If you select most load, Kasm will prioritize the agents with the most consumed CPU/memory resources. This strategy might be used in scenarios where you want to maximize the usage of specific agents before moving on to others, which can help optimize compute costs. Least Kasms is similar to the least load option, but in this strategy, instead of looking at the overall resources currently being utilized, it looks at the number of Kasm sessions, The priority goes to the agents which have the least number of existing Kasm sessions. This difference is very important to understand because not all workspaces utilize the exact same amount of resources. This strategy can be optimal whenever you want to maximize performance across your agents and also maximize the user experience. The last strategy we have is most Kasms. In this strategy, the system will prioritize the agents with the most number of existing Kasm sessions. This can be useful for maintenance windows because all the sessions can be concentrated to a few specific agents. The next setting you can configure is called the search alternate zones. If this is enabled, whenever a user requests a Kasm session within a certain zone, and if no resources are available in that zone, Kasm will try to create the session with the resources available in a different zone. This feature can be used to limit the wait time that you see during scaling events or whenever there's a high usage. The next setting is the proxy connection settings. When enabled, this allows for connections to be routed through a different server. When disabled, the agents communicate directly with the user that is requesting a session. You need to set the proxy hostname to the IP or fully qualified domain name of your proxy servers based on your infrastructure. The default value for this is whatever the request host parameter holds. In my demo environment, I would set this to teja.kasm.technology, which is where my Kasm web app that includes the proxy service is hosted. However, for multi-region configurations, you will want to set this to the regional load balancer that you will be connecting to in that particular zone, and set that to either its domain or IP address. The next setting in the proxy connections is the proxy path. This is the base path that is appended to the Kasm connections for passing through into Nginx. The default value for this is /desktop. And finally, we have the proxy port, which is the port to use for the proxy server. The default value is 0. When it is set to 0, Kasm will attempt to automatically determine the correct port based on the request sent by the user. Now let's move on to the demonstration. Before I show you the live demo on how to set up a zone, let me first showcase the demo environment that I have here. I have two servers. The first one is running the Kasm web app that includes services like the proxy, share, API, and manager. On the second server, I installed the Kasm database role, which includes a Postgres service and a Redis service. This environment is trying to imitate a basic multi-server Kasm deployment. Please note that I do not have any load balancers in my setup. So I will log into my Kasm deployment, which is hosted at teja.kasm.technology. In my admin panel, I'll go to infrastructure and then zones. By default, you can see there is only one zone that is named as default. But I want to create a geographical zone. So I'll click on Add Zone here, and I'll set the zone name to US Ashburn. For the allow origin domain, you can set this to the default value, which is the request_host parameter that dynamically extracts the origin domain from the user's request. But for a better security practice, you may set this to the base domain of your deployment. So I will set this to teja.kasm.technology. The upstream auth address needs to point to the Kasm API server where the connections can be authenticated against. I'll set this to teja.kasm.technology since this is where my API server is running. If your setup involves an API server that's behind a load balancer within the specific zone, it's essential to specify the IP or fully qualified domain name of that API server correctly. I'll leave the load balancer strategy to least load, and since I do not plan on adding any more zones, I'll just disable this search alternate zones because I only have one zone. I also don't have any static agents, so I'll just disable prioritize static agents. In the proxy settings, you can set the proxy hostname, which is the host name of the proxy server where you want the user requests to be routed through. The default value is request_host, but I will set this to teja.kasm.technology since this is where my Kasm web role is installed, which includes the proxy server. I will leave the proxy path as desktop and the proxy port as 0, which will automatically determine the port based on the incoming user request. If you're going to use RDP, you can also enable the RDP HTTPS gateway, and you can also choose to proxy your RDP connections. So I'll set the RDP HTTPS proxy name to teja.kasm.technology once again. And the RDP HTTPS proxy port, I'll set it to the default one, which is 443. And that's it. I'll now go ahead and save this zone. And you can see a new zone has now been added to my Kasm deployment. But as you can also see, it is not associated with any managers at the moment. So I will need to associate the current manager to the newly created zone. In order to do that, I will log into my deployment here where the Kasm web role is installed. I'll first go ahead and stop Kasm. I'll then go ahead and open this file, which is at opt kasm current conf app api.app.config.yaml. In this config file, I need to search for a parameter named zone name and change it to my newly created zone. So I will search for zone name here. And as you can see, the zone is set to the default zone. I will now change this to my newly created zone, which is US Ashburn. I'll go ahead and save this file, and then I will start Kasm back up. Once the Kasm services are started, I'll go back to my deployment, refresh this page. I will log out, log in back again, go back to infrastructure and then zones. And as you can see now, our newly created zone is now associated with the manager on this instance. Now that we have created a zone, we also need to create a pool in that zone. A pool is simply a logical grouping of similar servers for the purpose of load balancing your Kasm sessions. So essentially, when new agents are provisioned with auto-scaling, they must be associated with a pool. And that's why we need to create a pool. There are two types of pools that Kasm supports: Docker agents and servers. The difference between them is that a Docker agent pool is a grouping of individual Docker agents. On the other hand, a server pool refers to a group of servers that the users connect to directly. Once you create a pool, you can add an auto-scaling config to your pool. There are different settings that can be configured here. Let's understand what they are and how to configure them. The first type of setting is called the standby settings. This refers to the amount of resources that the system needs to keep always available at any given point of time. If the number of available resources fall below this value, new agents are created. If the number of resources rise above the value, existing agents are deleted accordingly. When configuring the number of standby cores and memory, it's crucial to consider both the typical number of workspaces needed at any given time and the resource demands of those workspaces. As previously mentioned, not all workspaces consume the same amount of resources. For example, a workspace running an Ubuntu desktop typically requires more cores and additional RAM compared to a workspace that's only running a Chrome browser. The next setting is called the downscale backoff. This setting prevents the system from prematurely deleting agents when the number of available resources temporarily exceeds the set values for standby resources. By defining a specific time period for this setting, you can ensure that resources are not downscaled too quickly. Then we have the agent override settings, which allow you to manually adjust the resource allocations specified in the VM provider settings when provisioning new agents. This can be useful for customizing the compute resources for your auto-scaled agents. Lastly, we'll set up our VM provider for auto-scaling. Essentially, Kasm communicates directly with the provider's API to automatically create and delete resources. Currently, Kasm supports a number of cloud providers such as AWS, Azure, DigitalOcean, GCP, and OCI. And OCI being the provider, which is what we'll be using in this video. Let me now give you a demonstration on how to create a pool in an autoscale config with OCI. The first thing I need to do is to create a pool. So I'll go to Infrastructure and then Pools. I'll go ahead and click the Add button to create a new pool. I will name this pool as US Ashburn Docker Pool, since this pool is meant to have Docker agents. I'll select the type to Docker agent because once again this pool is supposed to have Docker agents, and then click Save. So as you can see, a new pool has now been created. Now that the pool is created, we can now go ahead and create an autoscale config. So I'll click on all autoscale configs here. And by default, I do not have any autoscale configuration. So I'll click on add. And I'll name this as OCI Auto-Scaling. I'll set the autoscale type to Docker agent, and this needs to match with the pool type, which is also Docker agent. I'll select the pool that I just created, which is US Ashburn Docker pool, and you can enable aggressive scaling, and when enabled, the system may take more aggressive measures to provision raw compute resources, but I am going to leave this as disabled. I'll select the deployment zone to US Ashburn, which is the zone that I just created, and then I need to set the standby cores, and as I said, this is the number of cores that the system tries to keep available at any given point of time. So I'll set this to 6. And I'm not going to use any GPUs, so I'll set the standby GPUs to 0. And for the standby memory, I'll set this to 8000. Please do note that this value is expected to be in megabytes and not in gigabytes. So 8000 means 8 gigs of memory. The downscale backoff refers to the amount of time that you want to wait before the system downscales the agents. The value is expected in seconds, so I'll give it 3600 seconds, which is 1 hour. And now we are in the agent override settings. As I already said, you can override the number of compute resources that you want to allocate to the agents that are being provisioned. So I'll set the agent cores override to 6 cores, and the agent GPUs override to 0 because I don't need any GPUs, and the agent memory override to 8. Now, do note that this takes the value in gigabytes and not in megabytes like the standby memory. So I'm only going to give 8 here. And finally, you can also give your Nginx cert and private key here. If you want to use SSL for your newly provisioned Docker agents, you can go ahead and set those up here by giving your certificate and your private key, and they will be automatically installed on your agents. Since I don't have any certificates and I'm not planning on using SSL, I'll just put an empty space for both the Nginx key and the Nginx cert here, and then click on Next. And this will now take me to the VM provider configuration. Over here, I'll choose the provider to OCI or Oracle Cloud, and I'll name this as OCI config. And then here comes the OCI specific settings. To find your user OCI ID, just log into your OCI dashboard, go to your profile, and you can find your OCI ID over here. So just copy it and paste it here. Next, you also need to create and provide Kasm with a key so that Kasm can communicate with OCI on your behalf to create and destroy new compute instances. To create a new API key and add it to your OCI dashboard, you can follow these steps. First, I'll create a new directory called .oci. Then I'll go ahead and execute this OpenSSL command to generate an RSA key. And as you can see here, the OpenSSL command only created the private key. But we also need the corresponding public key because that is what we will need to submit on our OCI dashboard. In order to generate the public key from the private key, I will use this OpenSSL command that takes in the private key and prints out the corresponding public key for that private key. And as you can see now, we also have the public key. So I'll go ahead and copy this public key to my clipboard, log into my OCI dashboard, and in my profile settings, I'll go to API keys and then click on Add API key. I'll choose paste a public key here and then paste the copied public key that I just generated. Click on Add, and this is going to add the key. And it also prints out the public key fingerprint, and we need to submit this to Kasm. So I'll copy this, come back to my Kasm deployment here, and in the public key fingerprint field here, I'll paste my fingerprint. We also need to give Kasm our private key so that it can communicate with Oracle Cloud API. So I'll go back and copy my private key and paste it over here. You can also choose the region where you want to deploy your new agents. I'll choose the default one, which is US Ashburn 1. Next up is Tennessee OCID. So you need to paste the OCID of the Tennessee that you are using here. And then you also need to give the OCID of your compartment. So on my OCI dashboard, I have already created a new compartment that I'm going to use to test the auto-scaling deployment. So I'll copy the OCID of my compartment here and I'll paste it in my Kasm dashboard. Next, you can submit your network security group OCIDs here to make sure that your network security rules apply to the newly provisioned agents. In my case, I have already created a new network security group called auto-scaling test, and I will use this with my deployment. So I'll copy the OCID here and paste it in my Kasm deployment. Also note that this accepts the OCIDs as a list, so I'm going to make sure that I enclose them in quotes like this, and I also need to enclose them within brackets like this. And you can assign multiple network security groups to your agents because this accepts a list of OCIDs. The next setting is the maximum instances, and this is the maximum number of compute instances that you want to be able to provision regardless of the need for available free slots. So if you don't want to create, let's say, more than 5 instances, no matter the available system resources, you can set this to 5. So this means Kasm will not create more than 5 compute instances. 5 is the maximum. I will set this to 2. The next option is the availability domains, and this accepts a JSON list consisting of the availability domains where the OCI compute instances may be placed. So I'm going to set this to Ashburn 81, Ashburn 82, and Ashburn 83. And then you can choose the OS image that you want to install on your compute instances. You can refer to the OCI docs to see all the available images, but we recommend that you use Ubuntu 22.04, which is what we will be using here. This is the image that I'll be using, so if you just click on it, you can find the image OCIDs over here for different regions. I'm going to use the US Ashburn 1 image, so I'll just copy this image OCID and paste it in my Kasm deployment. And then you can also select the shape for your compute instances. I'm just going to set this to standard E4 flex. And then you can set the number of CPUs that you want to allocate to your compute instance. I'll set this to 6, and I'll set the flex memory to 16 gigs. Now in OCI, there exists a concept called burstable instances. This setting right here enables you to set a base CPU utilization level. So if I set this to 12.5%, this means that I set the amount of resources to 12.5% or 1/8 of these number of cores, which is 1/8 of 6 cores. And this is what I will be paying for. So in other words, I'm only going to pay for 12.5% of 6. And during periods of increased demand, the system can automatically burst performance to this number of cores to meet the higher usage needs. So this is a pretty neat feature that you can use with OCI to optimize your costs. And then I'll set the boot volume to 200 gigabytes. And I also get to choose the volume performance units for the boot volume. So this takes a value from 10 to 120 in multiples of 10, 10 being the default and represents the balanced profile. So I'm going to set this to 10 here. Next up is subnet OCID. So I'll go back to my OCI dashboard, go to subnets in my VCN, and this is the subnet that I already have. I want to link this subnet to my auto-scale agents. So all the new provisioned agents will be a part of this subnet right here. So I'll go ahead and copy the OCID of this subnet right here and paste it in my Kasm deployment. Next up is the SSH public key. If I want to SSH into my newly provisioned agents, I can put in my SSH public key here and then log in to the agents with my SSH private key. So let me go ahead and find my SSH public key here. I will copy it and paste it over here. Next up is the startup script, which is the script that we want to execute whenever a new agent is provisioned. So there is a startup script which is available on our GitHub. This script is publicly available on our GitHub repo called Workspaces Auto-Scale Startup Scripts. So I'm going to copy this and paste it here. Now, there are some modifications that I need to do here before I can submit this. The first thing is that I need to customize it to work with OCI. You can see over here, it's trying to get the IP address for different cloud providers like AWS, GCP, etc. So AWS is the default here. but I am not using AWS. So I'm going to comment this out and I'm going to scroll down until I find OCI. Here it is. And I'm going to uncomment this since I am using OCI. So this is trying to get the internal IP in OCI. That's pretty much the only customization that you need to do to make sure it works with OCI. So basically what this script is trying to do is it's trying to install the agent role on the newly provisioned compute instance. Also, since I did not configure an Nginx cert and a private key, I'm going to comment out these two lines. Because what it's trying to do here is it's trying to configure the agent with the SSL cert and private key. But I don't have an SSL cert and private key and I did not configure them earlier. So I just comment these out. And finally, we have the OCI config override. And this accepts a JSON dictionary that can be used to customize the attributes of the VM request. So I will use one of the examples that is provided in our docs, which is to enable the instance agent plugins. So I'll just copy this config right here and I'll paste it into the OCI config override. And that should be it. So I'm going to go ahead and click on finish here and the auto scaling config has now been created. So this should automatically trigger the provisioning of new Docker agents because we don't have any agents as of now. And if I now come over to my Docker agents, you can see a new agent has been kicked off. It has been provisioned. You can see the status is starting and I can confirm this by logging in to my OCI dashboard. And over here in my compartment, you can see a new compute instance has been provisioned and it is in the running state with 6 CPUs and 16 gigs of memory. So it's going to take a little while for this agent to check in to our Kasm deployment. And when it does, we should be able to see the internal IP address of it. So I'm going to keep refreshing this page until that happens. And there we go. It looks like the agent has checked in and you can see the internal IP address reflected over here. This is part of the subnet that we have configured before. And this means our auto-scaling config is now working. It is able to create new agents. So let me now go ahead and try to install and open a workspace. So I will go to workspaces, I'll go to registry and let me add a workspace. Let me add Firefox. So I'm going to click on install here and that's going to try to install this workspace on my newly created Docker agent. So if I go to workspaces over here, so you can see a red triangle on the Firefox tile over here. That means the image is still being downloaded. And we can actually check the progress of this by directly logging in to our newly created agent. So in order to do that, I'll come back to my OCI dashboard over here. I'll copy my public IP address. And since I have configured the SSH public key, I can SSH into my agent by using my private key. There you go. I'm now logged into my agent. Let me do sudo docker images. And you can see Firefox is finally available. So if I go back to my workspaces, refresh this page, you can see the red triangle no longer exists. That means the image has been downloaded. So let me try to open this up. And there we go. So if I go ahead and launch multiple workspaces and install multiple workspaces so that the available number of compute resources exceed the standby values, it's going to provision a new agent. So let's see if that works. I'm going to go to workspaces and I'm going to install some more workspaces over here. So as you can see on our existing Docker agent, the CPU and the memory usage has gone up and it exceeded the standby values that we set. So it went ahead and created a new agent for us right here. And I can confirm that from my OCI dashboard. You can see there is another agent that now exists and it's in the running state. So once again, it's going to take a little while for this agent to check in to our Kasm deployment. So I'm going to refresh this page here and hopefully there we go. It has checked in, so I can go ahead and open up additional workspaces. So Kasm is going to maintain the number of standby cores and standby memory that we have set in our autoscaling config. And if the current utilized cores and memory exceed those numbers, it's going to provision new agents. If I go ahead and delete these sessions over here, that's going to reduce our CPU and memory utilization, and that is going to trigger Kasm to delete additional agents. So let me check that. I'll come to admin, infrastructure, Docker agents, and it's not going to immediately downscale because of the downscale backoff that we set, which is set to 1 hour. So it's going to wait 60 minutes before it deletes one of these agents. All right, so that will be all for this training. You can find all the helpful links in the description, and thank you.